Hello students, this is project 2, part 2. In part 1 I showed you the steps in order to get started with your project, and I showed you how to choose your topic and where to find these topics. So either you're going to choose to work with the sample mean or the sample proportion, and then I showed you where to get the data. You're going to go back to D2L and you're going to select quantitative data if you chose to work with the sample mean. If you work with the sample proportion, then you're going to be working with qualitative data. And then you're going to go to the topic list and you're going to select the topic that goes with your data. So if you chose to work with the mean, the sample mean, you're going to either choose the variable height or weight or age of the players. If you chose to work with the qualitative data, which is the first data set, you're going to select the variable solitary confinement or gun control or political affiliation. And then based on what you select, you're going to copy the topic and you're going to bring it over to your project. So for example, I will be working with the weight when it comes to the sample mean, and I will be working with the solitary confinement when it comes to the qualitative data or the sample proportion. And then I copied both of these topics here, which is the inference topic. The other part, which is going to be collecting the data, today I will show you how you're going to select 30 values from your data set, whether you're working with the mean or working with the whether you are working with the sample mean or you are working the sample proportion. I will show you how to select your data using simple random sampling. You can use another method of your choice. We know now the difference between the sampling methods that we used, and you can use any one of them. So to go to the data, first I will show you how to sample from quantitative data. If you're working with the sample mean, I'm going to download the sheet. This is going to be an Excel sheet that has your data. Enable editing, and then you're going to get started with the editing. So I chose the weights. This is the variable that I chose. As you can see, there is the names of the players, and then the team, and then the position, and then their heights, their weights, and their ages. These three variables are the quantitative variables that we're going to work with. So I will be working with the weights in pounds. All right, so I want 30 data values. The first thing I'm going to do is to just number 1 to 30. So I'm going to say 1, 2, 3. And I'm going to select my data, and as if I am populating, I'm going to choose 30 values. This is just to make sure that I select 30 values. And then I'm going to label this. Let's say this is the index of my data. I don't care about that one. I should have said that is the index actually. All right. I'm going to choose now the index randomly. Notice how this data is labeled from 2 to 1035, I believe. So because that is labeled from 2 to 1035, I'm going to generate random numbers from here. So I'm going to say here, rand between, as if I am selecting from these numbers. I have them like on pieces of paper, and then I'm selecting randomly from between 2 and 1035. So this is one of them. And now I'm going to populate. So I will have now 30. As they are highlighted, I'm going to copy them and paste them in place as values. The reason why I have to do that is because if I don't, then each time I press enter, the random variable is going to run again, and it's going to generate another number for me, and that is going to change everything. All right, now I'm just interested in the weights. I'm interested only in the weights. So now I have the number of the row that has the data. For example, number, let's say 97. 97, if you look at 97 here, you'll see this is Brian, and it should give us this weight, 220. Sorry, it's Willie, and it should give us the weight of 175. So that is just basically the number of row. Now that we selected the rows, we have to select the weight that corresponds to that person with that number. It's just easier to do it this way. So I'm just going to say index. I'm going to use the function index, and then it's asking about the array. I want to choose from the array of weights. So I'm just going to select all of it by clicking on the letter E, and then comma. I wanted to select the index. So that is the row number. That is the row number that I'm selecting from. Just close it right here and click enter. Now I'm going to populate this. And as you can see here, it gave me the weight of 175 here. This is the smallest number that I can find, which is easy to find here. So you can verify the rest of the data. You can also find the names of these players by using the same function. So index, and then you're going to select the array of names, which is the array A. So I'm just going to select it, and then comma the index, which is the row number that corresponds to that number or that name. So I'm going to populate again. You see here, this is Willie, just like we expected. So our selection is accurate. I have to verify the central limit theorem for means. So the central limit theorem for means, it says as long as n is less than 5% of the population size, then it's okay. So for the means, the verification is very simple. If it's 30, then it satisfies the central limit theorem, and I can move on. Now, what I can do here, I can import this data into my sheet. Just like I said before, I usually delete this table. Usually I delete the table, okay? And then I can bring my table from here. So I'm going to create this as a table, or you can just copy and paste it. So I'm going to go here and I will paste it. It's not going to be a table, but if you create it into a table here, it's going to be a table. So I'm just going to go insert and then table, regular table, and then click OK. And I did not change this one. You can change it. You can say number, and then you can select this table, copy, and you can go ahead and paste it here. So gonna delete table, and then I'm gonna indicate that it satisfies the, okay, I'm gonna enter it here, and here the central limit theorem, I'm going to say it satisfies the central limit theorem because n is less than or equal to 5% of n. So this is the central limit theorem basically for this data. And again, since we don't actually need the names, you can skip that step altogether, but you have to indicate the index and the weight. Sometimes you just copy the number and the weight and skip the index, because the index is just my tool in randomizing my selection. So this is how we're going to do it for the sample mean. Let me show you how we're going to do it for the sample proportion. So we're going to go and download the data, and we're going to use a similar technique. The only difference is we have to verify that the central limit theorem is going to be satisfied. And then here we go. All right. So again, I'm just going to say number 1, 2, 3, and I'm going to select 30. Oops. I could go to 50, it's fine, because I know like sometimes the central limit theorem is not met and I have to add more numbers. But I'm going to start with 30, and then I'm going to put the index right here. The index is basically the number here, the number in front of the row. So this spans from 2 to 302. So I'm just going to select equals rand between 2 and 302. So basically I'm selecting any number between those two numbers randomly, and I'm going to populate. While it's highlighted, I'm just going to copy and I will paste it as values. This is going to ensure that those numbers don't change on me while I'm doing it. And then you're going to copy solitary confinement, and I'm going to put it right here. Let me just make this a little bit bigger. So now I want to find the data value that corresponds to the index. So for example, 40 should correspond to neither. All right, so let's say here equals index, and then from the array, I'm going to select from the array of solitary confinement, comma, the number of rows, those are the index, and then click enter, and then I'm going to populate. So as you see here for 40, it's neither. So that means I did this correctly. I don't need to find anything else, so I am ready to switch this into a table and copy and paste it. But before I do that, I have to make sure that I am working on the right thing. So for solitary confinement, I want to perform a hypothesis test at alpha is equal to 0.01 to see if there is enough evidence to show that less than 40% of the voters support solitary confinement. So that means p hat that I have to compute has to be supporting solitary confinement. So I'm just going to count how many people here support. I'm just going to copy the word support, and I'm going to paste it over here so I can count it. Set copy, and then paste it here as a value. All right, because I don't want to copy a formula. And then I'm going to count how many people support solitary confinement in my sample. So I'm just going to say count if all of these, okay, and the criteria is going to be the word support, and that's why I copied it. So 16 people out of 30. Now I'm going to say p hat is equal to 16 divided by 30, since I sampled 30. So this is p hat. Now for the central limit theorem, n times p times 1 minus p, this has to be greater than or equal to 10. So now I'm going to find if this condition is met using p hat, of course. So this is going to be n, which is 30, times 30 times p hat times, open parentheses, 1 minus p hat. The answer is 7. I would say if it is greater than or equal to 5 or more, then you're going to be okay. Let's try to add more data to our data right here. So what I'm going to do, I'm just going to select the last ones, and I'm going to add maybe 60. I'm going to double it. Okay, and then same for the index. I'm going to go ahead and add more. I'm going to find the numbers randomly between 2 and 3,007, 305. And then I'm going to go all the way down to 60. And I'm going to copy that, and I will paste it as values. And then I'm going to try to run this function one more time. Here we go. So now I have everything. I'm going to count the supporting. I'm going to choose my range again. And then click enter, since I don't need to change the reference. So that is 24. I'm going to say 24 over 60, 0.4. So as you can see, it gave me 7.2. As I run this, it's going to be around this value, so there is no need to double your data again. I would say if it's greater than 5, feel free to go with it. It's going to be all right. Another thing that you can do is to make sure that your data is normal. If your data is normally distributed, then you can make sure that it's going to follow the central limit theorem no matter what. I'm going to copy this table, and before I copy it, I'm just going to actually copy maybe 30 only, since 30 was satisfying the central limit theorem. So I'm just going to turn this into a table, and then I'm going to copy that table, and I will paste it into my project. So here is the other table, and then I have to write the central limit theorem here. I'm going to say n times p hat. First, I'm going to say that p hat is equal to, of course, p hat you can insert and go to equation, and then from equation go to accents, and then select the hat accent, and then type p equals to, and then type outside equals to, and then find the answer on Excel here. If we choose to use the original one, which was 16 out of 30. P hat is actually this value right here, so I'm just going to copy that and I will paste it over here. And then I'm going to say the central limit theorem is satisfied because n times p times 1 minus p is equal to this number, and you can change it to greater than or equal to 5, because even 5 is going to be all right. So if it's greater than or equal to 5, it satisfies the central limit theorem, and we can proceed. And then you're going to describe your sampling technique that you used. In my case, I used a simple random sampling, so I'm going to say I used Excel in order to use the simple random sampling technique by selecting randomly from the available data, and then using the index function to locate the corresponding data that I'm looking for. And then you're going to explain your specific technique that you used. You don't have to use the simple random sampling technique. This is part 2 is done. Part 3 is going to be, you're going to explore your data through some descriptive statistics. So if you chose the sample mean, you're going to compute the sample mean and the sample standard deviation for your data. So for the first part, I closed the sheet because it didn't work for me, but you can basically copy your data and then go to an Excel sheet, and then you can paste your data there, compute the mean and the standard deviation, the sample mean and the sample standard deviation. Since I'm working with tables, you can basically compute the mean for the weights at the very bottom. So here is your table. You're going to go to formulas, and then you can use the function average, and then this is your range. You're going to select your range and click OK. It's going to compute the average, and then you're going to say, okay, so this is the mean, and then you're going to compute the standard deviation. Of course, it's going to compute the sample standard deviation. Just going to click OK. So this is the mean and this is the standard deviation. You're going to copy these data into your project. I'm not going to do that since you can already do that part. And then for the option 2, if you choose the sample proportion, then you're going to compute the mean and the standard deviation using the formulas. We know that the distribution of sample proportions, the mean is equal to the population proportion. You're going to provide the sample proportion, which is p hat. We computed that, and then you're going to compute with p hat, you're going to compute the standard deviation and the mean. The mean is basically the sample proportion p hat, and then the standard deviation is, you're going to compute it using the formula p hat, square root of p hat times 1 minus p hat divided by n. So here is the formula that you will be using. This is the mean for distribution of sample means. It's going to be square root of p hat times 1 minus p hat divided by n. We don't have p so far, so we're going to stick to p hat. We computed that previously, so you should be able to compute. Sorry, that's not the mean, that's the standard deviation. So here's the standard deviation. We know that the mean is equal to the sample proportion, so the mean is equal to p hat that we computed. After you compute these formulas, you're going to put them in your project right here. So that is if you choose the second one. Make sure that you clearly label all of your statistics. You will use them in the next part of the project. So make sure that you label them correctly. This is how you're going to use it here. So go to insert, go to equation, and again, let's say 1 sigma. Subscript, we're going to say the subscript, or where is the subscript here? Here, script. So you can choose this one. You can say here sigma. So I'm going to delete everything. And then sigma sub. And then this box, I'm going to have the accent with the hat. I'm going to put p at the bottom. Is equal to square root of, and then you're going to put fraction inside. Top, you're going to put an accent with a hat. It's going to say p hat. Click outside so it doesn't extend the hat. Yeah, it's kind of tricky. 1 minus, so we're going to put an accent again, and then p. Similar for the mean. So this is this part. Part 4, you're going to find confidence intervals, and you're going to start the hypothesis testing. So in this part, you will calculate the confidence interval and conduct a hypothesis test for your data set. For the hypothesis test, you will be using the null and alternative hypothesis provided, which is it's in the topics, and we already wrote these down. So this is the hypothesis for sample mean and the solitary confinement. This is the one I chose for the sample proportion. So I already did this part. So this is basically going to depend on what you chose. If you're doing the sample mean, then you're going to select this one, and then the sample proportion, you're going to select this option. The confidence interval, we want to calculate a confidence interval. You're going to use the Excel sheet to make sure that your calculation by hand is accurate, but you're going to construct a 90% confidence interval. For the sake of saving some time, you can bring in the sheet, and then you can plug in the information, and then you're going to take a picture or a screenshot using the snip tool, and then paste the values here. So let me do that. So if I chose the sample mean, I'm gonna create confidence interval for means. So I'm just gonna click on the confidence interval for means, and then I'm going to put the sample mean I computed, the sample standard deviation I computed again, and then the sample size is 30, and then I'm gonna change this to 90. I'm gonna delete these, and I'm gonna go to the sheet and try to put these numbers I got from the sheet. So here is the mean. I'm just gonna copy that, and I will paste it over here. Oops, reference. I should have pasted it as a value. And then we go here again. I compute this, copy it, the standard deviation, and then I'm going to paste it here as a value as well. So this is the information I have. What I need to copy and paste is basically the first part. So I'm just going to use the snip tool. This is the snip in tool. And I'm going to take a picture of my work. So I'm going to click new, and then select only the first part of my work. And then I'm going to go ahead and I will paste it over here. Although you will be required to show the work by hand, but this is just a way to check. This is just to check that your answer is accurate. Of course, you're going to compute the margin of error by hand using the formula provided, and then you're going to add and subtract the sample mean if you're working with the sample mean. Let me just go ahead and write the formula for you really quick before we move on. So it's going to be x bar plus or minus t sub alpha divided by 2 times the standard deviation, the sample standard deviation, divided by the square root of the sample size. T sub alpha divided by 2 is can be computed using the formula. First of all, you're going to find alpha. Alpha is 10% since this is 90. So alpha is going to be 100% minus 90%, which is 10%. So alpha is 10% or 0.10. Then alpha divided by 2 is going to be 0.5% or 0.05. After you find this, you're going to find t sub alpha divided by 2 by using t inverse of 95%, which is 90 plus alpha divided by 2. So it's 95%. So 90 plus alpha divided by 2, comma, the degree of freedom, which is in this case 29, because n minus 1 is the degree of freedom, which is 30 minus 1, that is 29. So you're going to compute it using this formula right here. Let me just double check that it's the right one. So it's equal to t inverse of 95, 0.95, comma, the degrees of freedom is 29. This should be the t that we're looking for. That's compared to the t here. It is exactly it. And then you're going to say, well, x bar plus or minus t sub alpha divided by 2, which is this number. X bar is this number, times s, which is this number, divided by square root of n, which is 30. And then you're going to compute that. Once you're going to use the plus sign, once you're going to use the minus sign, the plus sign is going to give you the upper bound is x bar plus t sub alpha divided by 2 times s divided by square root of n, and the lower bound is equal to x bar minus t sub alpha divided by 2 times s divided by square root of n. So you can do each part individually, or you can do it at once. I'm going to do the first one and you do the second one, because it's just copying and then changing the sign. So x bar is this cell right here, comma, not comma, sorry, plus t sub alpha is this one, times s divided by square root of n, 30. So that is the upper bound, and then the lower bound, you can just copy that. So I'll let you do the second part. So this is the upper bound. Let me just double check that it's right. 199, no, 213. And what I got here is 213. So it's the same. All right. And I will let you do the other part, which is the upper bound. All of these computations should be shown, and you should do it by hand. Yours is going to be different because your numbers are supposed to be different than mine. The next part is we're going to do the same for the proportion. So if we have the proportion, we will do exactly the same, and then you're going to compute the same, construct a 99% confidence interval. So you're going to do exactly the same. You're going to change the level of confidence, and you're going to compute the upper bound and the lower bound with a different confidence level. If you're working with a proportion, then your confidence interval formula is going to be p hat plus or minus z sub alpha divided by 2 times the square root of p hat times 1 minus p hat divided by n. So we computed p hat and z sub alpha divided by 2. Let's say we're computing it for this one. So alpha is basically 100% minus 99%, which is 1%. So 1% is 0.01. So this is alpha. Alpha divided by 2 is going to be this number divided by 2, which is going to give you 0.005. So that is alpha divided by 2. To find z sub alpha divided by 2, you're going to say this is equal to norm inverse of 99 plus alpha divided by 2, comma the mean, comma the standard deviation. I'm going to compute it right here. This is equal to norm inverse or norm.s.inverse. Either one is right. And then the probability is 0.99 plus 0.005, comma the mean, comma the mean is 0, comma 0, comma 1, the standard deviation. I did it backwards. So this is the z value that you're looking for. Using the sheet, you're going to go to confidence interval for proportions, and you're going to plug in your numbers. You're going to plug x and n, or compute p hat right away. We computed x 16, we computed n, which is 30, so p hat is this number. And then we want it to be at 99% confidence level, so 2.5758 is the z value that we're looking for, which is I computed right here. But you have to do the formulas by hand in the same manner here. The upper bound is going to be p hat plus z sub alpha divided by 2 times the standard deviation. The lower bound is going to be p hat minus z sub alpha divided by 2 times the standard deviation. So that is that part. You're going to do it for both confidence intervals. Same variable. I just did it differently because I wanted to save some time, but you're going to stick to one variable. So if you worked with quantitative variable, you're gonna do a confidence interval 90% and then 99% confidence interval. And if you worked with the proportion, you're gonna do it for both of them the same way. And then you're going to give a brief explanation about the difference between the level of confidence, how it affects your intervals. This has to do with the margin of error that you computed. For example, 90% confidence level is going to lead to less margin of error, or the margin of error is going to be a little bit lower. A 99% confidence level, this is a big confidence interval. As a result, the margin of error is going to be bigger, and you're going to explain that and give me the numbers and screenshots if possible. And then you're going to perform hypothesis testing based on the inference that you chose. So for example, if you chose quantitative data and you're working with the sample mean, you're going to perform a hypothesis testing at alpha is equal to 5% to see if there is enough evidence to show that the mean weight of MLB is more than 202 pounds, and that's going to be a right tail test. So you're going to say, you're going to go to confidence interval for, you're going to go to, hypothesis testing for means. You're going to put the mean here, and you're going to change this to 100, so 202 is the suggested mean. And then you're going to plug your sample mean that you computed from your data, which is, we computed to be 206.8274. Don't forget to paste it as value here, otherwise it's going to give you wrong reference. The standard deviation, we computed that as well. So it's just going to be, here is the standard deviation, copy, and we're going to paste it as value here as well, right? And then the sample size is 30, and the significance level is 0.05. So in this case, this is what you're looking for. You can copy this data. You can copy each one individually using the snip tool. You can even copy this shape right here. But basically what you're going to say, we're going to fail to reject a null hypothesis. That means we don't have enough evidence to support the claim that says that the mean weight of MLB players is more than 202. So we're going to fail to reject the null hypothesis. Of course, you're going to write your null hypothesis. You're going to write your alternative hypothesis for mean. So you're going to say the null hypothesis states that the mean is 202, and the alternative hypothesis, or A, states that the mean is greater than 202. And then you're going to do your testing, and you're going to paste the result here, and you're going to interpret what the result means. Similar for hypothesis testing for proportions. So you're going to go to the sheet that says hypothesis testing for proportion, which is, I think, the sheet before that. The proportion, of course, you're going to look at your hypothesis that you're testing. So I chose solitary confinement. The null hypothesis is 40%, and you're testing at alpha is equal to 1%. So here you're going to say, which is exactly what I copied and pasted here. So the null hypothesis is 40%. And so here is, you're going to say the null hypothesis, H naught, states that the P is equal to 0.40. And then the alternative hypothesis states that P is it greater than or less than? So you have to double check here. Less than. So it's going to be a left tail test. Less than 0.40. And then you're going to use this data, and we have alpha is equal to 0.01. I'm just writing this down to see how we're going to plug it. So 0.40, and then less than, this is less than. The sample size is 30. And then I'm going to change that 30, and then the number X was 16, and then alpha is 0.01. So what you're going to say, you're going to fail to reject the null hypothesis because there is not enough evidence to support the claim that you're going to read the claim again. So the claim says less than 40% of the voters support solitary confinement. This is the claim. We don't have enough evidence to support that claim. As a result, we're going to fail to reject the null hypothesis. That doesn't mean we're going to accept the null hypothesis, but we don't have statistically significant evidence to reject the null hypothesis. So that is the language that we're going to use. And again, you can just take a picture. You can snip it using the snipping tool, and you can paste it there. You might need to show some work by hand. You can watch the videos on D2L and do that part. And this concludes your project. I hope this video helped you understand how to start a project and how to select your numbers and work through the process of the steps. If you have any questions, please let me know.